Today we're going to talk about the power rule for integration. So as I said in the previous video, that whole integral of x to the n dx being equal to x to the n plus 1 over n plus 1 plus c was not the power rule. That's because we actually have a power rule for integration. The power rule for integration says if you have a function of x being raised to a power times the derivative of that function of x dx, then your integral is going to be that function of x to the n plus 1 power divided by n plus 1 power plus c. So shorthand, if you've got u being raised to a power times that derivative of u with respect to x, then it's just going to be u to the n plus 1 over n plus 1 plus c. So this is actually a substitution game. We're going to do this thing called u substitution. So when we integrate here, what we're going to do is we're going to pick whatever's being raised to a power, and we're going to call it u. So we have this 3x squared plus 4 being raised to the third power, and then we have times 6x dx. We're going to call this u. So we're going to let u be equal to 3x squared plus dx. Then the derivative of u with respect to x, du dx, would be 6x. Well, this du over dx, if I multiply both sides by dx, I would end up getting du is equal to 6x dx. So now I have u being 3x squared plus 4, which fits right here, and I have du being 6x dx, which is right here. I can use this u substitution to get the integral of u to the third du. Well, that's something that we know how to take the integral of. That's going to be u to the 3 plus 1 over 3 plus 1 plus c. So now we have u to the 4th over 4 plus c, but the whole thing was I was trying to integrate with respect to x. My answer shouldn't be in terms of u. Well, what is u? U is 3x squared plus 4, so I'll replace that u with 3x squared plus 4 and have 3x squared plus 4 to the 4th all over 4 plus c. I highly encourage you to take the derivative of this and make sure it matches the integrand. If you do, you would bring the 4 down, leave the inside function alone, and multiply it to the derivative of that inside function, which would be 6x. The 4 you brought down would cancel with this 4, and we would have 3x squared plus 4 to the third times 6x, which does match that integrand. Write it out and do it. Now, what did I say? I said we want to pick u to be the thing that's being raised to a power. Well, as you can see here, nothing's being raised to a power, except this radical is really being raised to the 1/2 power. So we'll let u be x squared minus 3. Then our du dx, our derivative of u with respect to x, would be 2x. So if I multiply both sides by dx, I would see that du is equal to 2x dx. So then this right here, this x squared minus 3 is u, so I have the square root of u. And then the 2x dx is equal to du, so I have the integral of the square root of u du. Well, the square root of u is u to the 1/2, so I'm taking the integral of u to the 1/2 du. That's going to be u to the 1/2 plus 1 over 1/2 plus 1 plus c. So we have u to the 3/2 over 3/2 plus c. But we don't divide by 3/2. Instead, we multiply by 2/3. So we have 2/3 u to the 3/2 plus c. But again, we were trying to integrate with respect to x, so our answer should be in terms of x, not u. But u is x squared minus 3, so our final answer will be 2/3 times x squared minus 3 to the 3/2 plus c. All right, let's look at example C. What's being raised to a power? X cubed plus x squared minus 3. So we'll let u be x cubed plus x squared minus 3. Then du dx, the derivative of u with respect to x, would be 3x squared plus 2x. So then we can multiply both sides by dx, and we get du is equal to 3x squared plus 2x dx. Now here I can take this 3x squared plus 2x and move it out of the fraction, out of the numerator, and that gives me 1 over x cubed plus x squared minus 4 to the 4th times that 3x squared plus 2x dx. This x cubed plus x squared minus 3 is my u. That 3x squared plus 2x dx is my du. So then when I use my u substitution, I get 1 over u to the 4th du. Well, looking back at the rules we had talked about, I don't know how to take the integral with u in the denominator, but I can bring it up and give it a negative exponent. And the integral of u to the negative 4 with respect to u would be u to the negative 4 plus 1 over 4 plus 1 plus c. So I have u to the negative 3 over negative 3 plus c. We can bring this u down to give it a positive exponent and bring the negative up to the 1, and I have negative 1 over 3u to the 3rd plus c. Again, we were integrating with respect to x, so our answer should probably be in terms of x. Let's replace that u back with that x cubed plus x squared minus 3. And I have 1 over 3 times x cubed plus x squared minus 3 all to the 3rd power plus c. Again, I highly encourage you to take the derivative of your answer and make sure you get the integrand back that we started with. Let's do some more examples. Here, the integral of x cubed plus 5 all to the 7th times x squared. So we'll let u be whatever's being raised to the power x cubed plus 5. Then du dx, the derivative of u with respect to x would be 3x squared. But I notice a little problem here. This matches u exactly to the 7th, but this is just x squared. And I need it to be a 3x squared. I can't just stick a 3 in there because multiplying by 3 would change the entire problem. The only number you're allowed to multiply by that doesn't change anything is 1. So we're going to multiply by a fancy one. I'm going to multiply by 3 and 1/3 because what is 1/3 times 3? That's 1. So if I stick this 1/3 times 3 right here, I'm really just taking that x cubed plus 5 to the 7th times this fancy 1 times x squared dx. Now the 1/3 I don't need. It's just a coefficient, so I can bring it out front here. And I have 1/3 times the integral of x to the 3rd plus 5 all to the 7th times that 3x squared dx. This now matches my u exactly. This now matches my du exactly, and we just have this lingering 1/3 that'll just carry through. So when I do my u substitution, that gives me 1/3 times the integral of u to the 7th du. So that's going to be 1/3 times u to the 8th over 8 plus c. That 1 over 3 times that u to the 8th over 8, that's going to give me a 1 over 24 times u to the 8th. But again, we need to plug back in what u is, so we get 1 over 24 times x cubed plus 5 all to the 8th plus c. Let's do another example. The integral of 2x cubed plus 5x over x to the 4th plus 5x squared minus 3 all being raised to the 4th dx. Again, we're going to let u be whatever's being raised to the power here, so that's x to the 4th plus 5x squared minus 3. Then du would be 4x squared plus 10x. So then that's du with respect to x, the derivative of u with respect to x, multiply both sides by dx, and we get du is 4x cubed plus 10x dx. Well, if I rewrite this, right, where I bring this 2x squared plus 5x out here, 2x cubed plus 5x doesn't match this exactly. It's off by a factor of 2. So ideally, I would just multiply a 2 here to get that 4x cubed plus 10x. But if I just multiply by a 2, it changes everything. So I need to multiply by a 2 and a 1/2 to counteract that. But the 1/2 is the one I don't need, so it goes on the outside. And then when I distribute this 2 in here, I have this 1/2 times 1 over x to the 4th plus 5x squared minus 3 all to the 4th times, here's that 4x cubed plus 10x dx. This now matches u exactly inside here. This now matches du exactly out here, and we just have a lingering 1/2. So now I have 1/2 times the integral of 1 over u to the 4th du. I can't integrate this in the denominator, so I bring it up and give it a negative exponent. And I end up with 1/2 times u to the negative 4 plus 1 over negative 4 plus 1, which is negative 3. So I have 1/2 times u to the negative 3 over negative 3 plus c. That 1/2 and that negative 3 combine to get bring the negative up, negative 1 over 6, bring the u down to give it a positive exponent, and I have negative 1 over 6u to the third plus c. Of course, we need to replace back what u is, and we get negative 1 over 6 times x to the fourth plus 5x squared minus 3 all to the third power plus c. All right, let's look at f here. The integral of 7x to the fourth times the cube root of x to the fifth minus 7. Whatever's all being raised to a power is what we're going to choose for u. Well, instead of all to a power, it's all being cube rooted, which is the same as all being raised to the 1/3. So we'll let u be x to the fifth minus 7. Then the derivative of u with respect to x would be 5x to the fourth. When I multiply both sides by dx, I get that du is equal to 5x to the fourth dx. But as you can see here, that 7x to the fourth and that 5x to the fourth don't match. I can't just stick a 5 in there without changing it, so I'll take 7 times 1/5 times 5, because this right here is really 1, x to the fourth times the cube root of x to the fifth minus 7 dx. And so now I don't need the 7 or the 1/5, so I pull them out, 7/5 out. This 5x to the fourth dx is exactly equal to du, and this is now the cube root of u. So I have 7/5 times the integral of the cube root of u du. That's the same thing as 7/5 of the integral of u to the 1/3 du. This I can integrate using the rule we talked about previously, and that's going to be 7/5 times u to the 1/3 plus 1 over 1/3 plus 1 plus c. So that gives me 7/5 u to the 4/3 over 4/3. We don't divide by fractions, so instead that's 7/5 times 3/4 u to the 4/3 plus c. And that ends up being 21 over 20 u to the 4/3 plus c. But like we said before, we don't want to leave this in terms of u, so we'll plug back in what u is, and we get 21 over 20 times x to the fifth minus 7 to the 4/3 plus c. All right, let's do another example here. Here we have integrating the fifth root of x to the fifth minus 5x to the third plus 15x minus 1 all to the fourth times x to the fourth minus 3x squared plus 3 dx. Well, we'll let u be what's under the radical. Oh, that's to the fourth power. So we'll let u be that. U is going to be x to the fifth minus 5x cubed plus 15x minus 1. Then the derivative of u with respect to x is 5x to the fourth minus 15x squared plus 15. Multiply both sides by dx, and we get du is 5x to the fourth minus 15x squared plus 15 dx. Notice these don't match exactly. They're off by a factor of 5. I would need to multiply this by 5, 5, and 5 to make them match exactly. So I stick a 5 here, but I can't just multiply by 5. That would change everything. So I also need to multiply by a 1/5. I don't need that 1/5, so I bring it out. Then now the 5 distributed here, this whole thing right here equals my du. Everything under here, right here, equals my u. So I now have the fifth root of u to the fourth du. So now I have 1/5 the integral of u to the 4/5 du, which is going to be 1/5 u to the 4/5 plus 1 over 4/5 plus 1 plus c, which gives me 1/5 u to the 9/5 over 9/5 plus c. Dividing by 9/5 is the same thing as multiplying by 5/9. So I have 1/5 times 5/9 u to the 9/5 plus c. Notice these 5s are going to cancel. So I'm left with 1/9 u to the 9/5 plus c, which if you wanted to put it back in radical form would be 1/9 times the fifth root of u to the 9th plus c. But we cannot leave our answer in terms of u. We plug back in what u is, and this big answer is 1/9 times the fifth root of x to the fifth minus 5x cubed plus 15x minus 1 all to the 9th plus c. Let's do an application problem. Suppose the marginal revenue for the sale of a product is given by negative 30 over 2x plus 1 quantity squared plus 30, where x is the number of units sold. Let's find the revenue for the sale of 100 units. As we discussed previously, the revenue function is the integral of the marginal revenue. So we're going to take the integral of negative 30 over 2x plus 1 squared plus 30 with respect to x. Using my sum and difference rule, I'll break this up into two different integrals. It's the integral of negative 30 times, I brought this up and gave it a negative exponent, 2x plus 1 to the negative 2 with respect to x, plus the integral of 30 with respect to x. Now this one's easy, that's just going to be a 30x. This one's a little bit more. I'm going to have to use my u substitution. So I'll let u be what's being raised to a power, 2x plus 1. Then my du is going to be 2 dx. Well, what is negative 30? Negative 30 is negative 15 times 2, so I just separated them. So now I have negative 15, this is u to the negative 2 times this is du. Then we have this plus the integral of 30 dx. I don't need the negative 15, so I pull it out. Replace this with u to the negative 2, replace this with du, plus the integral of 30 dx. So now I can say this is going to be negative 15 u to the negative 2 plus 1 over negative 2 plus 1, which is going to be negative 15 u to the negative 1 over negative 1, plus this is going to be 30x plus c. Now you might be asking, why didn't I add two c's? Well, c is just a constant, and a constant plus a constant is another constant, so we just need 1 plus c. And so now, negative 15 over negative 1 will reduce to a positive 15. Bring this u down to give it a positive exponent. And I have 15 over u plus 30x plus c. Well, that's pretty messy because I've got this in terms of u and x. So I'm going to have to plug back in what u is, that 2x plus 1. And I get my revenue function is 15 over 2x plus 1 plus 30x plus c. But I want the revenue for 100 units. Well, if I plug in 100 right here, I don't know what C is. But remember, if you don't sell any units, then you didn't make any revenue. So the revenue for 0 units is $0. So if I plug 0 in here, 15 over 2 times 0 plus 1, plus 30 times 0 plus C, that will give me 0. Well, that gives me 15 over 2 times 0 is 0 plus 1. That gives me 15 over 1 plus 0 plus c equals 15. So now I have 15 plus c equals 0, or c equals negative 15. So my actual revenue equation is 15 over 2x plus 1 plus 30x. And instead of plus c, the actual is negative 15, or plus negative 15, or minus 15. So now I can plug in 100 units, 15 over 2 times 100 plus 1, plus 30 times 100 minus 15, gives me 15 over 201 plus 3,000 minus 15, which gives me 2,985.074627. Word problems are asked in words. They should be answered in words. What is the revenue for 100 units? Rounding to dollars and cents. The revenue from the sale of 100 units will be about $2,985.07. That's it for now.